In this video, I present to you my DIY watering system. It's very easy to build. You just print out some structural parts and mount 12-volt electronics on them. Then, the controller measures the soil's humidity content. If the humidity is below a target level, a small pump starts to pump water. I'll give a complete tutorial on how I assembled the controller and close with a list of materials you'll need if you want to build your own controller. I also integrated a voltage regulator into the system. This feature allows you to adjust the pump's water flow precisely. Additionally, a small digital display shows the corresponding voltage, making it very easy to set up an effective and customized watering strategy for your plants. You can add a tank as big as you want, ensuring that even when you're on holiday, your plants will continue to grow healthy and happy. This system provides both flexibility and peace of mind, knowing your plants are well cared for. I've already covered some other grow tent topics with tutorials that may benefit you in your growing journey. I produced this video in a way that it can also be used as a printout. That means you can use it offline, or even just print some single pages of it. All the design that are shown can also be downloaded. Hey! My name is Daniel, I am from Germany, and I will be your host. Let's automate our grow tent. This is the structure of this video. First, I will explain the specifications that guided me. Then, I will show you how to build the controller and present a longer video of the system. I will close with a bill of materials. My initial venture into the world of indoor growing began with cultivating mushrooms. The cultivation of mushroom happens like that of plants inside grow tents. Through this experience, I acquired good knowledge about do-it-yourself grow tech. To keep it easy for everyone, I focused on solutions that are plug and play and require no programming knowledge. Since summer 2022, I published 22 tutorial videos on my playlist that teach all the biological and technical tech you need to know about how to grow mushrooms indoors at home. After finishing these tutorials on the complete mushroom grow cycle, I upgraded my Martha tents to professional grow tents. Then, I also decided that I wanted to create a tent for growing plants and figure out the best way to create the needed environmental conditions. Then my focus shifted to plants. I started cultivating vanilla plants, a tropical species that thrives in high humidity environments. The vanilla has adapted well to the artificial environment. To further test my plant setup and check if my lamp is suited for the plants, I added some plants at the bottom of the tent. Mushroom tents do not have high amounts of UV lights, so I needed to change the humidifier tech to ensure that the water does not start to bloom with algae and clog the humidifier. Since a grow lamp creates a higher temperature environment, the humidity automatically drops. Thus, all my plants were happy when I added the humidifier. Some growers of medical marijuana also use humidifiers to achieve the best environments for their plants. I also successfully cultivated tropical pitcher plants and peppers. This is the ventilation system that I use. Ventilation is especially important. If you do not let your lamp run 24 hours a day, it shuts off at a certain point. Then it gets cold, and all the cold air will gather on the ground, making the ground wet. Thus, I always use at least one fan on the ground. The fan creates a circular air movement inside the tent, ensuring the plant is always in the same good conditions. I also apply active air exhaust. The input air can be passive because the exhaust creates a suction effect. I do HEPA filter my incoming air to keep pests and dirt out. Insulate your tent from the ground. I used a rubber garage plate that can handle getting a bit wet when I mop the floor. On top of it I added a layer of XPS, or extruded polystyrene, which is thicker compared to EPS and offers better insulation value. It is also very moisture resistant, easy to lay, and durable enough to walk on, making it an effective floor insulation material. If you don't insulate your ground, the ground will be the coldest element in your tent, and you may always have wet spots on your floor when you turn off your lamp. But then life got in the way of my plant projects. I forgot to water them and treated them poorly, so I had to restart my project. This video marks the restart. I added the missing link, an automated watering system. Now, it doesn't matter if I skip 1 or 2 weeks, as long as there is enough water in the reservoir. Let's talk about the watering strategy. I would always place the watering spot next to the trunk. With that fixed, there are basically 2 possible principles left. 1. A slow dripper ensures constant moistening. 2. A fast dripper that releases water like a watering can or a small flood. This will not happen as often but will water a bit spontaneously. Either way, the water will diffuse through the complete soil. What you need to figure out is where you want to place your sensor and which humidity level you want to maintain. But after a few weeks, you will have found your optimal parameters. You could also use a small tube to create a pit in which to place the sensor. This way, you can further optimize your watering strategy. When you have a big pot with more than 1 plant, I would use a T-connector to water every plant at its trunk. I would place the sensor between them and use the fast watering strategy. Additionally, you might consider creating a dam around the plants to guide the water. In outdoor setups, simple time-related push systems are common. These involve a dripper combined with a timer that supplies the desired amount of water to the plants. The downside is that it's static. However, that's not much of an issue outside because any excess water just evaporates. But inside your tent, it's a different story. If you put too much water in, it ends up on the floor, and your plants can drown, which they definitely won't appreciate. That's why a pull system works better indoors. It uses a sensor to signal the pump to deliver just the right amount of water needed. This ensures your plants stay healthy without the risk of overwatering. So, I have designed a system that's really streamlined for ease and safety. It runs on a simple 12V power setup, really safe and also pretty easy on the wallet. Most parts, they're not just cheap, they're also super easy to get your hands on and you can 3D print them yourself if you like tinkering. Know some points, why it works great. First, safety first, the electronics aren't anywhere near the water, they're kept above water level, so there's zero risk of any electrical issues. Secondly, simplicity, you don't need to be a tech whiz for this, no complex programming and barely any soldering. Third, maintenance is a breeze, everything's inside, nice and neat, while the water system does its thing outside, pulling water as needed. Things to keep in mind. Durability, just a heads up, the 3D printed last as long as something off the shelf and they're easy to produce. Monitoring, there's just one sensor in there, so it's pretty basic. Also, remember to check the water tank now and then because it won't tell you when it's empty. Final thoughts? It's perfect for anyone who wants a reliable, easy to manage watering system. Especially if you've got a big setup or can't always be there to water things manually, this system will save you a ton of time and keep your. Let's check out the installation of the system. First we start by printing out the base plate. The design is optimized for a 0.6 mm nozzle. I did use the color black and cheap PLA. Printing should be no problem. Next you will need this controller, XHM214 humidity controller. We will use the same screws for the complete system. Senk Kopf Universal Schraube PZ Antriebo 3 mm x 12 mm. Simply use a screwdriver to attach the board to the mount. Get your voltage regulator ready. With it you can regulate the water output of the pump. Here you see my system directly after setup. Input air is throttled with a HEPA filter. As I use 2 tenths, I need an Y connector for single exhaust that goes out of the building. Get a small 12V pump. This the one I use. 12V DC small 370 water pump with DC motor, low noise, large water flow. Since most pumps lack the blue mounting element, I will include a universal pump mount that can be used with zippers. Connect the pump to the DC output of the voltage regulator. With this adapter you should be able to install any mini pump. Remember that I use a 12V system. If you do need another adapter, feel free to contact me, and I am sure we will find a solution for your problem. You can use cheap LED cables. I used 22 AWG or 0,5 mm superscript 2. You will need a tool for stripping the wires, and a second tool for crimping the ferrules. You should not dismiss these tools. Buy them and use them. Next, create this simple cable tree. Use one 30 cm cable and one 15 cm cable. Use the correct tools and ferrules. Install the power adapter on the end with the black ferrules. Always use ferrules when you use a screw terminal. Connect the humidity controller to the 12-volt cable. The red 12-volt power line are to be connected to the relay of the controller. The relay will let the current pass when the soil humidity is below your target. Connect the power from the relay to the input side of the voltage regulator. When adjusting the voltage, keep in mind that you might need to turn the knob for a long time before seeing any change. Since it is an endless knob, it doesn't matter how long you turn it. Next, we will tidy up the design using a cable zipper. I used the middle rack to secure the cables. Print out the cable cover. It will be installed with 4M3 12mm screws. Now you can be happy, your controller is ready. I hope you enjoy the design. This is the backside view. Next, we will print out the parts for mounting the controller. The printing process is easy and fast. Clean your parts for the next step of the assembly. First, I will install the hanger. It is secured with 2 screws. Since you want the flexibility to place the controller anywhere when you change your plant, I also added some feet. Each foot is secured with 2 screws. This base foot lock is optional. I don't use it, but I wanted to leave the possibility open. The standard feet are rigid enough. Maybe I should just delete this component. Now the controller can stand on its own or be hung in its desired working place. Let us now create the necessary parts for the water management. They are also easy to print. Here you see the angle elements and a T-connector. I have an extra Thingiverse file for the T-connector. This is the basic water hose mount. It is a feed-through design. If you want to add some extra mounts later for a cleaner setup, you can use this open hose mount. This angled water hose mount is a possible end piece. Depending on your watering strategy, you might want to use it. For very low water flows, it is ideal for dripping. For high water flows, I recommend using the feed-through mount. Use this cable to connect the controller to your 12-volt power supply. The length depends on your setup. Again, please use wire end sleeves. We will use the same power adapter that we already used before. Secure the connection correctly. That can only be achieved when you used ferrules. This is the AC/DC adapter I use. The output is 12 volts and 5 amperes. Since power equals voltage multiplied with amps, it provides 60 watts. The hose is a standard one for outdoor irrigation systems. Here you can see that I already have the power cable ready, and the water hose from the outside reservoir is coming inside the tent, ready to be connected. Do not connect the power supply before the assembly is complete, otherwise the pump might start working. The middle pin is for the outflow of the pump. The pin on the side is for suction, so you should connect it to your water reservoir. As water type, I always use Brita filtered rainwater. This works also great with humidifiers. Next, you can plug in your sensor and mount it somewhere in the earth. Cut some water hose to a length that suits your setup. It should be long enough to allow you to experiment with the placement of the water input into or onto the soil. I simply inserted it, check the desired length, and then shortened it accordingly. Connect it to the center pin of the pump. Secure the water hoses with cable zipper. Since there is nothing left to connect, you may now power up your system. As you can see, the soil humidity is already at 93%. This is quite high due to some preliminary checks and experiments conducted prior to this documentation. There are several options to tidy up the cables. I went for the flexible cable conduits and the zippers. This already looks much better. Now it is even more pleasing for the eye. Now I moved the sensor and the water point to the desired location and the installation is thus complete. I think this build can be built by everyone and hope you have a good time building it. Let's take a look at a video again. In this video, I present my complete watering setup. It features a sensor that measures resistance between its legs, allowing the controller to calculate the soil's humidity. When the humidity drops below the target, the pump starts watering the plant. Simply place the sensor near the plant trunk and adjust the water flow speed to achieve optimal growing conditions. The system operates on a safe 12-volt electronic system, not dangerous for humans. The water tank is outside the tent, allowing for a large tank without UV light promoting algae growth. The controller can either stand or be hung, which is convenient when changing plants. The sensor's electronics are above the pump's water level, ensuring no risk of a short circuit. Consider adding proper ventilation. When you turn off the lamp, the temperature drops inside the tent due to reduced water retention in the air. A ground fan prevents water accumulation. Also, insulate your tent from the ground. If your plants need more airflow, just add more fans. They're inexpensive and can be placed anywhere. These are the main materials I used. This is the XHM214 soil moisture controller with a humidity range of 20 to 99% RH. Here you see the complete specifications of the product, and also the ways in which you can set it up. These are basic screws. They are universal, mainly for wood, and self-tapping. They do not mind any humidity. The LM2596 DC-DC step-down converter is with display. You can get one without, it is much cheaper. You could just also not use it at all. This is the pump I used. There are many 370 water pumps, this one has a mounting possibility. I noticed that many pumps do not have a mounting possibility, so I added a universal adapter. Then you can just use a zip tie and attach the pump. I used 22 AWG equivalent to 0.5 mm square standard LED cable. You should crimp the end of your cable before using screw connections. This is a good tool for stripping of the insulation. Female connectors for LED strip light. This is a basic watering hose. The inner diameter is 4 mm. Make sure to check compatibility with your pump. Let's close with some basic thoughts. Please share with us in the comments, how did you set up your grow tent? What would you improve? What do you do differently? How do you water? What is the greatest advice that you could give out? Whenever you produce something indoors, you are running a production system. The Kaizen philosophy comes from the Japanese word kai, meaning continuous, and zen, meaning improvement or wisdom. Kaizen is a daily process whose purpose extends beyond mere productivity improvements. It also seeks to humanize the workplace, eliminate overly hard work, and teach individuals how to conduct experiments on their tasks using the scientific method. This approach helps them learn to identify and eliminate waste in business processes. Overall, Kaizen promotes a humanized approach. The idea is to nurture the company's people as much as it is to praise and encourage participation in Kaizen activities. Please view growing as a journey to develop your character alongside your plants. I do the same. For example, this lecture consists of 108 slides. Of course, you can do whatever you want with your life and choices. But please remember to always be kind and helpful. There's so much suffering out there. Unless you've walked in someone else's shoes, how could you know why they behave the way they do? If you favor the door you chose over the other possible doors, then you devalue everyone who took a different approach. That is not the kind way. To be kind means to be relaxed. With this softness, you can then focus on your kaizen and improve the things that you love. These things you can then project into the world, see them grow, and spread joy. Before we end, I did put a lot of work into this lecture series. I hope you enjoy it. Maybe you want to consider to buy me a coffee? There is a serious reason why I ask. In life there is balance everywhere. Summer and winter, day and night, hot and cold, and so on. It's obviously natural that taking and giving is also a polarity that needs to be in balance. Only when there is balance can we, as humans, achieve harmony and genuine happiness. That means, if you take something for example from the internet, you should also give something back. Please check for yourself if your life is in balance. If you want, you can support me with a donation. That would be great. You could also support any other good project. Send someone a smile, leave somewhere a nice comment, or just be joyous and spread some love. Thank you for spending your time with me. I hope you like my solution. Try it out for yourself. Happy building. Auf Wiedersehen.